right, it's focused now. Okay. All right, here we go. We're on page 6. Understanding that there's a lot more to this little section than just those graphs. So one of the things that's in it is equations like this. So on your test, you're going to have to solve an equation like this. When we did these together, you know, the first time, I made a suggestion to you. There's lots of ways to do the problem, but I suggested that maybe we do what? Does anybody remember? Multiply everything by the common denominator. So I am going to multiply everything by the common denominator. And the purpose of that is to get rid of all of the denominators. So the first term would be 4x plus 20. This is a quantity, you're distributing the 4, plus the next term will be x squared minus 3x. And the last term will be 12x minus 8. Everybody good so far? Now, what kind of an equation is that? Look at it carefully. What kind of an equation is that? It's a quadratic. So let's get it cleaned up. Over here we have a 1x, so minus 11x, and plus 28. How did I get what? Hurry up. So that's 1x, and I bring the 12 over, it's negative 11. Now, what am I going to do with my quadratic equation? If it factors, I'm going to factor it. If it doesn't factor, I can always do what? This one does factor. So my answers are 7 and 4. Now, do you remember what we talked about with these kind of equations, though? We have to be careful of excluded values, extraneous roots. So what are my excluded values here? I only have 1, 3. I didn't get 3, so these are both good to go. No reason to suspect that those are wrong. All right, number 2. If you say divide by x, I will come unglued. We don't divide by variables ever. What are we going to do with this guy? Subtract, and then what? Factor. And then we're going to factor. So we're going to get our inequality set equal to 0, and then we're going to factor it if it's possible, and hopefully it will be possible. Then I'm going to draw my number line, and I'm going to put 2 dots on the number line. Where will those 2 dots go? The dots always come from the factors. So one's going to be 5 and one's going to be 0. The problem is an or equal to, so I'm going to color those dots in. I'm going to color in both dots. I only worry about not coloring them in if they're in the denominator, right? I don't have a denominator, so I'm not worried about that. Now I'm going to pick a number, and we like to pick 0, but we can't this time because you can't pick a dot. Pick any other number, but it can't be a dot. So 1 is fine, 1 is in here. If I put in 1, I get 1 times negative 4. Does that meet my expectation? Yes. Less than 0 means negative, and 1 times negative 4 is negative. So that works. So that's my answer, everything from 0 to 5. We did one like 3 yesterday. Do you remember doing one? It was on a quiz, and we reviewed it even though it wasn't on your quiz yesterday. So what did we say we were going to do with this guy? Subtract 6. Always, always you want to get 0, kids. And when I subtract the 6, I like to think of it as 6 over 1, because that reminds me that I need to do what? Find a common denominator, and the common denominator will be x minus 1. So this one's all good. This one needs an x minus 1. So I have x plus 2, watch it now, minus 6x plus 6. You remember you're distributing the negative 6 all the way through.
Now, does that get rid of the x minus x as well?
There's no, nothing's gotten rid of it. It's like when you have 2/3 and 5/3, when you add them together you get 7/3. That's exactly what we just did.
Okay.
I have two fractions with the same denominator, so I can write them as one fraction. All right, so then cleaning up everything, it looks like I have negative 5x plus 8. And now I'm going to go to my number line and I'm going to put 2 dots on it. One of the dots is at 1. And you can see that, I mean that was obvious. This one's not quite as obvious. So rather than guess, I'll just over to the side, work it out. Where's that dot going to be? It looks like it's going to be at 8/5. So I have a dot at 1 and a dot at 8/5. Well, they're open because I haven't colored them in yet. But I want to be careful here because I don't think I want to color in both of them. Just the 8/5 is going to get colored in. Even though it's going to equal 2, we know x can't be 1. X can't, it's an excluded value. It can't ever be included, so it's going to be open. All right, can I use 0 this time as my test number?
Yes.
So I'll put 0 in, and I get 8 over negative 1. Does that fit with what I want? Nope, because that's negative and that's positive. So 0 didn't work. Here's 0. It didn't work, which means this will and that won't. So my answer is everything from 1 to 8/5, including 8/5. All right? All right, what's your strategy for number 4, do you think? If it groups, we're going to group it. Does this one group? I'm thinking it doesn't look too good. But I love that that was your first thought. If it groups, it's just easier to group it. You don't have to, but it's easier. This one doesn't. So what are we going to do? We're going to think about PRRs.
It's negative 1.
And she's already done it. She says negative 1 works. So she saved us some trouble. We're going to find out if she's right. She is. Now, this problem that we are doing, when we get it factored, which is our objective, we're going to have 3 factors, right? And one of them, I already know. One of them is going to be x plus 1. Do not forget he's a root, so he gets a factor. Now the other 2 are going to come from this leftover stuff, right? So those would be x minus 4 minus 2. And that's less than 0. So I'm going to have 3 dots. Every factor gets a dot. Look at the degree of the polynomial. It's 3. So we're going to have 3 dots. And where are the dots going to be? Negative 1, 2, and 4. Make sure you put them on there in the right order. Open or closed? Open. Can we use 0 as a test point? Yep, 0's in here, so we're testing right here. When I put in 0, I get 1 times negative 4 times negative 2. Does that give me the kind of answer I was looking for? No, that comes out positive, I want negative. So this does not work, which means this will, and this will. So my answer is everything from negative infinity to 1, everything from 2 to 4. Okay? Now, I'm going to skip the next ones, are calculator problems. Let's do the no calculator ones first. So we're skipping to number 9 now. What are the excluded values? Okay, that's easy. What are the excluded values for number 9? 3, -3, and 0. Your excluded values are anything that makes the denominator 0. You can just look at the problem and see 3, -3, and 0. Okay, that's easy. And then sketch, okay, this is what we just did. Find all pertinent, label all important things, use limit notation to describe all asymptotic behavior. Okay, here we go. What's the first thing I'm going to do? Factor. I'm going to do that as I go, so that'll be x, what? -4 plus 3 over 2 times x squared plus 2x minus 3. So I took a 2 out of the bottom, and now I'm going to factor. And what am I going to get? X plus 3 minus 1. Oh, there we go. So our problem is going to be x minus 4 over 2 times x minus 1. Did I do that right? And I'm going to have a hole. And where is the hole going to be? I'm going to have a hole at whatever factor I canceled out, which was -3. Now I need to plot it. So what will be my y coordinate? What is it? Somebody confirm that? Is it 7/8?
Yeah.
So I'm going to go ahead and plot that, -3 7/8. Now, this is where all your attention is focused. Tell me about stuff.
We have a horizontal asymptote.
We have what?
Horizontal.
Where is our horizontal asymptote?
And 1/2.
Y equals 1/2. Brenton noted that the powers on the top and the bottom match. Therefore, we have a horizontal asymptote, and it's 1/2. Good. What else do we have?
Vertical.
Vertical asymptote where?
At 1.
At 1. X equals 1. Straight from the denominator, we have a vertical asymptote at 1. All right, what else do we have? Y-intercept where? At 2. That was 1, so here's 2. Let x be 0. There we go. There's our y-intercept. All right, one more thing. Where's our 0 or our x-intercept?
At 4.
At 4. Now, based on that, I think we have a very good idea about what this looks like, don't you? Would you say that's what it looks like over there? And over here, I got that intercept right there, so it looks like this. Everybody okay with that graph? As soon as we finish this problem, we'll go to lunch. Quit looking at the clock. So graphing okay? All right. Now, what does this use limit notation? Well, all right. Let me just ask some questions. Let's talk about that one and this one. And then let's talk about, where's my asymptote one? let's answer these questions and then you can go to lunch, all right? So here we go. These are the questions I want you to answer, so I'll number them so we can talk about them. Here we go. 1, 2, 3, 4, 5, 6, 7 questions. These will be easy. Look at your graph. That's why you did it. Number 1, tell me what the answer is. 1/2 from the bottom. Now that is not negative 1/2, that is 1/2 from the bottom. This is a Y value. Y's are vertical, they have tops and they have bottoms. We are approaching that asymptote from the bottom. All right, what about this one, number 2? What's happening there?
It's 1/2.
We're approaching 1/2 from the upside, from the top. This curve, as you head left to negative infinity, this curve is getting closer and closer to 1/2. All right? Now we're going to approach 1.
That's infinity.
1 is an asymptote. We're approaching 1 from the negative side of 1, which would be the left side of 1. What is happening to the curve? Positive infinity. All right, now I'm going to shut up and give you a minute. I want you to fill in the last 4 yourselves,
Wait, is
and then I'll check them for you.
negative 3 is a whole? Okay, so
We're saying as x gets closer to negative 3, what is y getting closer to? All right, you got number 4 answered? What'd you say for number 4, which is the limit as x gets closer to 1 from the right side? What did you say? I hope you said negative infinity, because that curve is going down, 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 down. Here is 1. Here is the right side. As we come in, we're going down. Did you get an answer to that one? What's the answer to number 5? 2. What happens where x is 0? We have a point, right? And when we have a point, what is the limit value always going to be? The y coordinate of the point. All right, what's number 6? 7/8. When we have a point, whether it's open or closed, doesn't matter. Aren't we heading toward a y value of 7/8? Yes, we are. What about 7? I haven't figured it out yet, so I get 2 over 2 times. Yes, if you said 1/5, you are exactly right. Where is 6? Isn't 6 a point out here on the graph, you guys? If you let x be 6, y turns out to be 1/5. Limit values of points. What are you doing? Give it to me. Limit values at points are the y coordinate, okay? You can always find it plug in x. The only time it's an issue is if it's an asymptote. And then it's either going to be shooting up or down, right? All right, when you come back, we'll do the calculator part. Wait. I need you back in your seats at 12:25. Back in your seats at 12:25. Do not be 1 minute late. Do not be 1 second late. In your seat at 12:25.